All right, guys, this is the build guide for the Alpha 2 night vision system. So real quickly, I'm going to go over the tools you need. You're going to need a multimeter, iron, screwdriver kit. You're going to need a 5/64 drill bit, two 2mm Allen wrenches, some Loctite, a pick, tweezers, clippers, solder. For your printed parts, you're going to need a left and a right pod, 2 diopters, 2 infinity rings, 2 tube retainers, a tube retainer tool, button cap, button support, button back plate, bridge. You're going to need 4 small sections of wire. That's some 32 gauge wire. It's not included with the kit. Included in your kit, you're going to get your button. I've already pressed over and soldered this one in place. This is onto the button PCB. You're going to get the 2 stow-off PCBs, a backboard, 4 leaf springs, 4 of these tiny pogo pins right here. I know you probably can't see that. It's just a really tiny pogo pin, a long pogo pin, your flexible button cover, cone spring, 3 small Allen head bolts, 2 of these shoulder bolts with washers. I've already gone ahead and soldered in 3 of these tiny pogos just because it takes some time, but essentially you're going to drop this pogo in on one side. It doesn't matter what side of the board you use, and you're going to use the tiniest amount of solder to solder this in place. Too much and you will destroy the pin. So drop your pin in place and then take your soldering iron. Grab my solder and just the smallest amount of solder. Just touch it with some solder and let the heat kind of soak it through. Then you should see a nice rolly pin on the other side. All these pins should roll freely and should be able to be pressed in. Sometimes if they can get a little bit of solder on them. This one's got, I don't know what it's got, some crust in there. But they should be able to all press in. Sometimes you get a little bit of solder, you can break them loose with some pliers. So they all press and roll. You should feel them be smooth on your fingers. All right. You're going to take your Fisher connector, also included with the kit, and you're going to cut the pins down about halfway. You're going to put them into the board so that the balls are on the opposite side of the Fisher. And looking at the board, we're going to call this the top, where this extrusion is. With the top away from you, the white dot of the Fisher connector will be on your left. So you're going to press that in there, flip it around, and then add a small amount of solder to all these pins. Just going to make sure it's good and melted in there. All right, a little bit more. You don't want to have a excess buildup, but you want these to be sealed. All right, so now you're going to take your spring, and the trick with the spring is you're going to put it in there and pull it off the board slightly. So what I tend to do is set the board like this on the table and have the spring away, because the goal is to not have the spring be straight. The spring is going to come out of this board at a slight angle. So you're going to go behind the spring from the front, add some solder, solder it in place, and your spring should be soldered in place. It's a little crooked to the side. You want it to be You want the spring so that it kind of sits off the board. I don't know how best to show this to the camera, but it sits off the board at an angle towards the top. So that way when it goes into your bridge, the spring can fully be compressed, essentially, without pressing into our solder joints from our Fisher connector. You can put some Kapton tape there if you want, but this works fine for preventing that touch. Now we're going to take our bridge. So the bridge, almost 99% of the time, this hole for the large pogo pin is going to be filled with something, like whether you PLA print it or FDM print it and it gets clogged, but you're going to run your 564 drill bit in there. And then I like to take a little bit of a bigger bit or a chamfer tool and just chamfer that backside, because sometimes the solder can flow forward through this and create like a bump pressing it away. But you're going to put your board into the bridge, and then you're going to drop in your pogo, and you're going to make sure everything seats good. What you want to see on the front side is just the slightest poke of that ball. You want that ball to just slightly poke through. We're going to set this here. Where can we set this? Set it back here. We just don't want to press that ball in. Then we're going to come in and we're going to solder this. Now this one you can use a little more solder because the ball's so far up the front that it takes a long time for it to soak all the way up there. All right, now that pogo pin is nice and soldered in, and that's our bridge board done, and you can remove it like that. All right, so now we're going to slide some of these hardware parts out of the way. We're going to continue soldering. So we have our flex boards. We have our spring connectors, or our leaf springs. You're going to depackage these. All right, these have a pretty clear top and bottom. The top has a ramp. So we're just going to remove these real quick. These are adhesive backed, so they have an adhesive backing that sticks them in. But you're going to have the open end of the spring. So the spring has an open end and like a front leading edge. That leading edge is going to go, how can I explain that? The open end is going to go towards this bar in the back. So you're going to just go like that. And then you don't need a whole lot of solder for this, but we just press the spring down with the iron and we add solder until it sticks to that pad. And we're going to do the same thing to the other side. You just set the spring on the gold pad. And then it should kind of, once you get a little pool of solder there, it should kind of flow itself into place. All right. Now on the back side, ooh, that's hot. On the back side, you'll have two gold pads. You'll take one of each color of your sections of wire. And so the way this works is in the tube, this will be facing like the opened end, the large end, it'll be facing like this. So on the right is always going to be your positive. So we're going to use white for the right connection and green for the ground connection. I'm just going to pre-solder these pads a little bit so we can just heat up the pad and stick the wire in there. Now it's good to have the wire going towards the leading edge of those springs. Just makes it a little easier. Running away from me here. Normally I do this all as a panel, so it's first time doing it like this. All right. So we have our wires connected there. And these are going to be left long, but we're going to trim 90% of that off. We're going to do the springs again. And when it's on this, in this thing, you can kind of see where the back edge is and the front edge. So I'm just going to put these on there. Sorry about that. Dogs were barking. All right, so we soldered those leaf springs on, and we're going to solder on these, and we want them to be running towards the open end. Just makes it easier. And like I said, these are going to sit in the tube kind of like this. So this one on the right is going to be our positive. So we'll just add a little solder here. All right, now our boards are done. So this is possible to do without the flex board as well. You just solder the wire directly to the back of the spring, and then you'll glue those in place. But I find that to be a lot easier. All right, so now we're gonna get into the pods. So my pods are a little butchered on the back here, but there's a notch on this board, and that notch will fit into the pod, and then that'll determine the clocking of the tube. It's already pre-done, you don't have to worry about that, just print them out. On the back of these boards there's a plus and a minus. That works exactly like you think it does. We're going to connect our positive to our negative on that, or a positive to a positive, negative to negative. But we have to insert the wires into the pods first. So when they're nice and long like this, I like to do a little 90-degree bend, and then you can insert them in and kind of wiggle them about, and they'll make their way out. Bent it too far forward. There's no real special channel for it, it's just open in there, but there's a, it's just giving me a hard time right now. There we go. So before we pull it all the way through, we got it partly through. You're going to fold this so the springs kind of touch each other. and then we're going to pull the, of course. Just catching right there for some reason. All right. We're going to remove the backing for the adhesive without pulling our wires through again. And this adhesive's pretty forgiving, so you can, if you mess it up the first time, you can kind of re-stick it. But there's spots in the tube for these to drop into, and you want to get it as far forward into those slots as you can. And then from the back side, I like to come in with a pick and just massage the glue in place. My lighting is just awful right now. I'll try and show you guys what this looks like in just a second. I get that in there. What the hell? I could do this 100 times first try, but the second I go to record a video on it, I can't get the damn things in their spot. And I don't know why my light is just not working like it normally does. All right, so you get them in their spots, you massage them down in place. And you want them to sit as far forward as you can. What is going on with this one? All right, there we go. I'm gonna give you guys a view of what that looks like. There's probably no way to show that to you. All right, I got no way to really show this to you because the lighting is just awful. But they sit into spots down in the tube, if you can see that at all. There we go. There's like channels in there, sits in there, they press in place, and the adhesive keeps them locked in. All right. Now you're gonna do that to both tubes. I'm only gonna do that to one right now, but I'm gonna skip to the second part and show you what we do. So you have your wires. Depending on how good you are or how good you're not, you're gonna wanna have very minimal slack here because there's not a whole lot of space inside. We're gonna start by prepping these boards on the circle pad side. We're just gonna add a small amount of solder to each one of these circle pads. And I normally clip these. This is going to be impossible to show this on camera when I solder it, but I'll clip these just the width of my finger away from the tube. Now I'm going to go ahead and strip these off, just the tiniest amount of stripping like a 1/4 inch, because when we prep this with solder, it's going to pull it back even more. So you want to just the tiniest amount. Now, I orientate this board so these dots are away, right? So that way, when the board is flipped into position like this, it's clocked how it should be. So I orientate that so the positive is lined up with the positive, negative lined up with the negative. And we want these wires to be coming straight off of this small board. So straight up and down off of that board. Just slowly take your time. All right, now if you have a lot of slack, you can add a twist in here, but I would like to pinch it and keep it kind of straight near this board at the top. Add your twist and push it straight in and into your clocking mark. And if it gives you trouble on seating in the tube because it's a really snug fit, it's a little aggressive sounding, but I take some channel locks and I make sure I get that alignment tab in there first, and then I just press with the channel locks and you'll have a nice flush fit. So it'll be absolutely flush, shouldn't sit proud. If it sits in a little bit, that's okay, but you don't want to sit proud of the tube. All right, now we're just gonna quickly do this other side as well. So same process, we stick our wires in. Fold it, remove the adhesive backer, and then get them springs in place. And then we press them in and just massage the, that adhesive so it's a contact adhesive, but you just kind of rub it over the bottom of that spring in that solder joint just to make sure it's got some pressure in there to keep it stuck. And there we go. Same thing, I'm going to pull it up towards the top and I'm going to cut about a finger width off and just leave a minimum amount of slack, keep them kind of spaced up. Use the old teeth strippers. Put a little bit of solder on these. A little bit more on that one. I've already prepped this board. Line it up. All right, and then we want those wires again to be coming pretty much straight off the board. I'm going to pinch it, add a twist or two, and then push it into the board. Line up our alignment point, and then press it in place with the channel locks. Doesn't take a lot of force, but this one is pressed in the wrong spot. I was experimenting with different clocking positions and I'm gonna use a different one here. There we go. It's in place, good to go. Now this is just excess wire. You can reuse it for whatever you want. I don't care. All right, there's our pods completed. Now we're gonna move on to the button. So you just fold over these tabs on the button, press them through the holes, bend them over and solder them in place. Keep your button as centered as you can. Our button support is gonna go over our button like this and kind of press on and just give it a little more rigidity. I forgot to mention, I like to use a little bit of super glue. And we'll just take some super glue and we'll put it on the PCB at a few points around the edge. And then we'll take our rubber button cover from the inside, insert it, and it's got a channel that the edges will catch on and it'll sit nice like that. And we drop our board in, and this is going to be a press fit kind of with that super glue in there as well. So you just crank it onto the housing and that'll hold nice pressure there while that super glue sets up. While that's drying up, you're going to take these are referred to as the nuts. It's kind of like a female bolt, but typically those are a press fit in there, but the print house messed up the print dimensions. They just had some shitty print quality. So these fit a little loose on mine, but those should be a very tight fit on yours. You'll press those nuts in there. You guys won't need these because I designed it out, but I have some washers. These are just a plastic printed ASA washer because again, the print house, I don't know, they scaled it or something in a weird way, and dimensionally the bridge was just not what it should have been. There's other parts too that were just completely fucked, but the bridges were usable, but they took some work. All right, so we're gonna take our pods and insert them on here. Now's the time, if you have Krylox glue or lube, you can lube up those joints and make it really buttery smooth, but it's not super necessary. And with that washer in there, it also makes it feel kind of nice, so I don't really care about that. But it should have a smooth rotation, shouldn't get caught up or anything. Okay, so now we can take our backboard and insert the pin and set our backboard in place. And we can take our back plate, and the Fisher connector has a nut on it. You're going to take that nut off, and the connector should fit through the back plate. And just like that, it kind of pops in place. We're going to put our nut back on. I'm going to put a little Loctite. This is where I like to put a little Loctite because those nuts come off pretty easily. So just a little blue Loctite. All right. Now I'm just going to go ahead and remove that whole assembly real quick because the board's not sitting exactly in there how it should. All right, so our board is in our back plate. This Fisher connector, the nut should sit probably like a millimeter below the edge of the connector itself. And then we can insert this back in. It's annoying that these keep falling out. All right, our 2 bolts, we're going to take these and put a little bit of blue Loctite near the end. These are going to go through the cone washer and in the back. And they should press in the first 3/4-ish, but if they don't, you can just screw them in a little bit. This is where I like to take this electric screwdriver and just let it run. You'll feel when it starts to connect right about there. And then just holding pressure is enough to get it at least a little snug. All right, now this is where you're going to tune your tension of your pods. So I like to take this on the front side just to hold it in place, and one on the back side. And just give it a 1/4 turn till it feels about right. You want it to have some stiffness to it so it doesn't just flop down. That feels about good. And then you want to be able to pull on both sides and kind of have them come up at the same time. It seems like this one's a little loose, so we're just gonna tighten this one a little more compared to the other one. Just about a 1/4 turn. All right, that feels good. All right, now's the point where we're gonna install the dovetail, which I did actually forget in the start. Your dovetail is just like this. It's gonna go, you're gonna remove your battery cap. Might have super glued it on a little bit. What the hell? All right, oops. Remove your battery cap. Your dovetail will slide into place, and it kind of fits in there a little tight. Now this screw goes in from the top. Depending on your print tolerance, that might not be the easiest initial fit. So you can take a, what size bit was it? You can take a 7/32 bit and just clean out this hole a little bit. Don't even need to use the electricity of it. Just run that bit in there just to clean that hole. And it's only about halfway down that it goes, and then your screw goes in there. And for the screwdriver, it is an Allen key, but for some reason these screws don't seem to fit Allen keys well. So I use a star bit. Just gotta find the right one. All right, so this is a T7. A T7 Torx on these. And with a lot of pressure, you're just gonna press down and screw it in at the same time. And it'll sit just below the surface of the dovetail. And all that does is there's a little channel in there that locks into. This one sitting a little loose. We'll crank it down a little bit more. But all that does is lock that dovetail in. It'll have a little bit of play to it because that channel has some movement, but that'll keep it locked in place. My T7's really worn out, so it's not grabbing this screw as much as it used to. All right, there we go. And then These screws go on the front. These are your purge screws. Just T7 again. And they just thread right into the plastic. And they cut their own threads as they go in. Just like that. All right, now this is pretty much the end. That is essentially how you build it. So I don't have tubes on hand right now. I do have a digital tube right here. This is a digital tube already assembled and built. There's a notch in there. There's a notch on your tube. You're gonna drop your tube in until it seats into that notch. This one, the cable, of course, got super fucked. But it'll seat into that notch and the tube won't be able to rotate. Your tube holder and your tube retainer will fit together fairly snugly like that. You'll drop that in and you'll rotate that, and you shouldn't have to worry about cross threading this. It's pretty hard to cross thread these threads, and that's in there. For your lens, all you're gonna do is you're gonna take your standard PVS-69 eyepiece, you're gonna rotate it clockwise until the cell comes out. You're gonna take that cell, put it in here, rotate it counterclockwise, and it'll suck the cell into it. I like to take a little bit of Krytox, or Krylox, whatever it is, and just put a little bit on these threads. It's probably too much. And that will help with the threading. It doesn't help with the initial thread is going to be pretty rough just because it's a print, but once you run it back and forth a couple times, it'll seat pretty nice. These diopter assemblies have some flex to them as well. So even if you do cross thread it or get it cross threaded, just push down on the side that's cross threaded on and it should flex over and jump back onto the proper threads. So a good trick is if you're not getting it to start properly, run it backwards slowly until you hear like a click or you feel a little click. There. And then run it forwards. And that's where the threads engage at first. So this one's going on kind of crooked, but like I said, you just jump it over onto the threads and it should be fine. Once you run it back and forth a couple times, it's really smooths it way out. Especially with that lubricant on there, it gets nice and smooth. There we go. If you have an FDM print and you have one of these, you can also just thread this on there and use this to kind of chase your threads a little bit. The problem is it's easy to kind of print the threads, but then when you're printing them on both ends, it makes it really hard because this is a really small pitch thread. Can't get this part to start. There we go. And then for your infinity stop, just thread those on. There you go. There you go. There's your Alpha 2. So to op test this, you're going to take your multimeter set it to continuity, check your multimeter first, and you're just going to test continuity across the positive and negative pins to make sure you don't have any shorts. This one, it beeped, but that's just because the digital tube is in the one side. Let me remove that. I printed this tool a little short. You should really print this tool thicker or longer. So the file will be a little longer for that tube. And we push our digital tube out. Back this one off as well. So you're going to take your housing, set it up like this, and check these. These shouldn't have continuity across them, but they do. Come on, man. Let's see, these ones also have continuity across? What the fuck? So it's saying we have a short somewhere, but maybe the jack is bad? Huh. That doesn't really make sense. It's saying we have a short somewhere, but I don't know where that could even be. Well, looks like we get to test it. So we're going to back these off. And we're just going to remove this whole back plate, and we can test the pods individually. So this right pin should go to your small one, the small half moon, and your ground pin goes to the large ground pad, and then check cross continuity to make sure you don't have any continuity between them. And we'll do the same on the other side. All right, so the pods are good. So it says our back plate is messed up. It must be the Fisher connector, actually. So our pogo should have continuity to this pin closest to the hole, or our cone spring should, just like that, and it should not have continuity to the outer pins. The long pin is a positive pin, should have continuity to these smaller ones. I don't understand where the short's coming from. Everything's testing fine. That's strange. I'm thinking this Fisher must be, something must be wrong with the Fisher connector. Because I did pull this connector out of another build that also had a short and I couldn't figure it out. So I scrapped everything apart of it. So now we're getting no, yeah, but we're loose as hell. Yeah, I'm thinking this Fisher connector is bad. I'll just have to swap that out for a different one because that should not happen. But yeah, that's pretty much how you build that fisher connector. I'm gonna say that's probably the fucked up part here, whether there's internal short to how it was constructed or something. Yeah, that goes the Alpha 2 build guide. Kits are available. Unfortunately, this isn't a super like piecemeal your own kit together project just because of the custom parts included. So there's no real way for you guys to get these parts because I had to actually custom make so many of the parts for this. But I really wanted to make this a DIY-able, very competitive housing. And yeah, hope you guys enjoy.